Hi guys, how are you? I hope you are all doing well. This is Somashekar Kalepalli. Welcome to Thermal Wing YouTube channel. This is my fifth video lecture on heat transfer course. Those who have watching this video, first subscribe to this channel, click like button. After watching the video, post your valuable feedback. What is the favorite topic in this video in the comment section. Last class I explained about what is meant by radiation and how the radiation is different from conduction and convective heat transfer. In this class, I will explain about the theories related to radiation heat transfer, that is Maxwell theory of electromagnetic radiation, Max Planck quantum theory, and the different types of electromagnetic radiation. There are two theories concerning the radiation heat transfer, that is first one, classical electromagnetic wave theory of Maxwell. Second one, Max Planck quantum theory. Electromagnetic wave theory of Maxwell. The theoretical foundation of radiation was established in 1864 by Scottish physicist called James Clerk Maxwell. According to Maxwell theory, energy is transferred during radiation by electromagnetic waves. Wave structure that is explained in detail. According to Maxwell's electromagnetic wave theory, light waves are related to changing electric fields and magnetic fields. Maxwell postulated that accelerated charges are changing electric currents gives rise to electric and magnetic fields. This theory describes the interaction of electric and magnetic fields. These two fields fluctuating together to form a propagating electromagnetic wave. Electrical and magnetic fields both are oscillating perpendicular to each other and both are perpendicular to the direction of propagation of radiation. And these rapidly moving magnetic and electric fields are known as electromagnetic wave or electromagnetic radiation, and they represent the energy emitted by matter as a result of the changes in the electronic configurations of the atoms or molecules. All electromagnetic waves travel at the same speed of light in vacuum. Speed of light in vacuum is equal to 3 into 10 power 8 meter per second. According to electromagnetic wave theory, the energy emitted from any source is continuously in the form of radiation and is termed as radiant energy. Observe the graphical image. Energy from the sun reaches on the earth's surface continuously by means of radiation in the form of electromagnetic waves. This is the most important point of electromagnetic wave theory of Maxwell. Max Planck quantum theory. In 1900, Max Planck proposed quantum theory. According to quantum theory, energy is radiated in the form of successive discrete packets known as quanta. In case of light, quantum of energy is known as photons. In Max Planck quantum theory, quanta means singular term, quantum means plural term. Max Planck quantum theory is expressed an equation E equal to h mu. E represents quantum energy of photon. H means Planck's constant. H equal to 6.626 into 10 power minus 34 joule second. Mu represents frequency of radiation. Max Planck quantum theory is applied to all forms of electromagnetic radiation. Wavelength and frequency of electromagnetic radiation in medium is related by lambda equal to c by mu. Lambda represents wavelength of electromagnetic radiation. It is measured in micrometer. Mu represents frequency of electromagnetic radiation. Frequency is measured in Hertz. C represents speed of light. This lambda value substitute in Max Planck equation. This equal to h mu becomes E equal to hc by lambda. Important point of Max Planck quantum theory is to, according to Max Planck quantum theory, the energy emitted or absorbed is not continuously but discontinuously in small packets called quanta. This is the important point of Max Planck quantum theory.
You can think of light as the flow of tiny particles called photons shooting out from the sun.
Differences between electromagnetic theory of Maxwell and Max Planck quantum theory is to, according to Maxwell theory, energy is transferred during radiation by means of electromagnetic waves, and the energy emitted or absorbed continuously by matter. According to quantum theory, energy is radiated in the form of successive discrete packets known as quanta of energy, also called photons, and energy is emitted or absorbed not continuously but discontinuously as small packets known as photons. That is the major difference between electromagnetic theory of Maxwell and Max Planck quantum theory. In actual practice, both the theories are useful to explain the radiation phenomena and properties. Types of electromagnetic radiations. These are the different types of radiations: gamma rays, X-rays, ultraviolet radiation, visible light, infrared radiation, microwaves, and radio waves. These different types of radiations are represented on electromagnetic spectrum. Electromagnetic spectrum represents the different types of electromagnetic radiations based on the wavelength and frequency. These different types of electromagnetic radiations are classified based on the wavelength and frequency. Observe this diagram. These are the different types of radiations based on the wavelength of the radiation. These are the major key points regarding electromagnetic spectrum. Is to first point, the electromagnetic waves are of all wavelengths traveling at the speed of light. Frequency and wavelength are connected by relation lambda equal to c by mu. Lambda represents wavelength, c represents speed of light, mu represents frequency. Both are reciprocal to each other. Higher the frequency, lower the wavelength. Frequency is measured in Hz, wavelength is measured in microns. 1 micrometer equal to 10 power minus 6 meters. Smaller the wavelength, higher the frequency, more power is the radiation, and also damaging. Example, X-rays and gamma rays are more powerful radiation. Gamma rays is a one type of electromagnetic radiation. Gamma rays are most powerful form of radiation, and it is having less wavelength and more frequency. They are emitted from radioactive materials and nuclear reactions artificially produced by radioactive isotopes such as cobalt-60, iridium 192, etc. Applications of gamma radiation: radiotherapy, sterilization industry, and astronomy. Gamma rays applications in medical applications are radiotherapy. Radiotherapy means it is a one type of cancer treatment. Gamma rays are more penetrating in matter and can damage living cells to a great extent. They are used to kill cancer cells or cancer tumors without having to resort to surgery. This procedure is called radiotherapy. Observe this sketch. Gamma rays application in sterilization. Sterilization is the process of eliminating of microorganisms and other bacteria. Here, sterilization of medical instruments and surgical instruments. Observe the sketch. Sterilization plant. In this plant, different types of medical instruments and surgical instruments are sterilized. Necessary for sterilization of medical instruments or surgical instruments reason is to implantable medical devices like heart valves, pacemakers, stents, and orthopedics must completely sterilize before they are used in patients to reduce the risk of infections or complications. That's why sterilization of medical or surgical instruments is needed with the help of gamma rays. Next application, astronomy. Gamma ray astronomy. Observe the sketch. It is a specially designed gamma ray telescope. This gamma ray telescope instrument designed to detect and resolve gamma rays from sources outside Earth atmosphere. The biggest gamma ray generator of all is universe. The gamma ray astronomy is the study of objects and phenomena that emit gamma rays. Gamma ray telescopes are designed to observe high energy astrophysical systems such as black holes, clusters of galaxies, neutron stars, etc. X-rays. X-rays are one type of electromagnetic radiation. X-rays are produced by bombardment of metals with high energy electrons. X-rays are having lesser wavelength and high frequency. X-rays and gamma rays are known as ionizing radiation. They are having high frequency and lesser wavelength and having more penetrating capacity. Applications of X-ray radiation is to medical imaging, mammography. Observe the sketches. These are the X-ray images produced with the help of X-ray machines. X-rays are a form of electromagnetic radiation, have higher energy and can pass through most objects including the body. Medical X-rays are used to generate images of fractured bones, injured objects inside the body for the examination of the doctor. Mammography. Mammography is the one of the application of X-rays. Observe the sketch. This is a mammography mission. Mammogram is an X-ray picture of the breast. Mammograms can be used to check for breast cancer in women who have no signs or symptoms of the disease. It is one of the application of X-ray radiation. Remaining types of radiations are in next class. Thank you guys. Thank you for your patience listening. If this video is worthy for you, click like button, subscribe to this channel, share this video with your friends. Thank you.